Hello everybody, let's graph this rational function. And to do so, we're going to start by factoring the numerator and the denominator. Let's do the numerator first. First thing I'm going to do is I'm going to pull that negative out. You don't have to, but I like to do it. You don't have to do it the same way as me. So, pull it out of everything, aka change the sign on everything. There you have it. And now, let's focus on what's inside the parentheses. We will factor that by grouping. So look at those first two terms. What do they have in common? Well, you could pull out an x squared of both of them. So do that. What's left behind? X plus 2. Do the same thing in the second two terms. So pull out a negative 9 and you're left again with x plus 2, which is good because this is going to be factored by grouping. So how do we go? Still have that negative out front, but now we've reduced our 4 terms to 2 terms, and again, factor out the common factor. So they both have an x plus 2, so factor it out. What's left behind? X squared minus 9. There you have it. That has been factored by grouping, but we can go further because x squared minus 9 is a difference of 2 squares. So the numerator, when it's totally factored, will be negative x plus 2, x minus 3, and x plus 3. There you have it. Let's factor the denominator now. X squared plus 2x minus 3 will factor as x plus 3 times x minus 1, because negative 1 times 3 is negative 3, and 3 minus 1 is 2. Now factor the other quadratic in the denominator. That is going to be, if we have x squared minus 5x plus 4, it has to be x minus 4 times x minus 1, because negative 1 times negative 4 is positive 4, and negative 4 minus 1 is negative 5. So there you have it, but we can simplify things. First off, notice we have a whole. So we're going to remove that whole. So in the numerator, we will have negative x plus 2 times x minus 3. In the denominator, notice we have 2 factors of x minus 1. So I will write that as x minus 1 quantity squared, a multiplicity of 2. So x minus 1 squared. And then we have our x minus 4. And we removed that whole, so we need to state the condition that x cannot equal whatever x value makes that whole 0, so negative 3. And now we have factored this thing, which means we're ready to start listing things. So what do we know? We know we will have x-intercepts by looking in the numerator at negative 2, comma 0, and another one at 3, comma 0. Let's find our y-intercept. Y-intercept occurs when you plug 0 in for x. Look at the original equation. If I plug 0 in for x, that would go away, that would go away, that would go away. I'd be left with 18 in the numerator. That would go away, that would go away. I'd be left with negative 3 there. That would go away, that would go away. So I'm left with 18 over negative 3 times 4. And we can simplify things. 18 divided by 2 is 9 over negative 3. 4 divided by 2 is 2. So over bibbidi, that thingy right there. That was a weird way to simplify it, but let's keep on going. 9 over 3 is 3, and so I have negative 3 halves. I simplified it weirdly, but whatever. I got it. You do your own thing, right? So y-intercept at 0, comma, negative 3 halves. What else? We should go ahead and state our whole. So the whole is occurring when x is negative 3. So go ahead and plug negative 3 into the simplified equation, and let's see what we get. So negative 3 plus 2 is negative 1. Negative 3 minus 3 is negative 6. Over negative 3 minus 1 is negative 4, and that's being squared, times negative 3 minus 4 is negative 7. And let's simplify things. Let's look. Negative cancels, and a negative cancels, and a negative 4 squared is the same as a positive 4 squared. So we can simplify things. So I have 6 over 4 squared is 16 times 7. 6 over 16 can be simplified to 3 over 8 times 7. And so I have 3 over 8 times 7 is 56. So I have 3 over 56. And so I can state that I have a whole at negative 3, comma, 3/56. There you got it. Two more things to list. We will have vertical asymptotes by looking in the denominator. X minus 1 squared is giving us a vertical asymptote at x equals 1. And x minus 4 is giving us a vertical asymptote at x equals 4. So last thing, horizontal asymptote. Notice the degree in the denominator is greater than the degree in the numerator. So that means we will have a horizontal asymptote at y equals 0. So we have all our information. Now let's sketch it in. So 1, 2, 3, 4. 1, 2, 3, 4. That should do me x-wise, I think. Let's mark our vertical asymptotes at 1, and 4, and what else? We have x-intercepts at -2, so we can put that on there, and also at +3 right there. We know we have a y-intercept that is -3/2, so that's going to be down here, somewhere right around there. We know we have a hole at -3 and +3/56, which is just going to put me just barely above the x-axis there. And what else? Vertical asymptotes, got it. Horizontal asymptote at 0. So now we're just going to sketch this in. So the curve is fairly defined to the left of that first asymptote there. Based on those pieces, I have to start down, curve up like that, and then back down to my horizontal asymptote at 0. So it's got to look something like that. On the asymptote right there at x equals 1, notice the multiplicity is 2. The factor in the bottom is squared, which means since that one starts down, this one has to start down as well. So I have to curve up like that. And then the last one, again, since the multiplicity of x minus 4 is just 1, an odd number, my tails have to be on opposite infinities. So I have to start down since that tail starts up. And there we have it, and that should do it.